Yeah, we'll be discussing about these three charts: Gantt chart, bullet graph, and box plot today. We have covered remaining charts in previous session, right? These are little,
Yes.
little advanced charts, or we can say uh, to show, to represent a bit of complex data. We use this chart. Okay, let us go through Gantt chart first.
Okay.
Gantt chart is used to represent a duration. Uh, let's say this much duration is taken for this activity or this event. In those scenarios, we will use Gantt chart. It is date is must for it. Okay. Hello.
Okay.
Yeah.
Okay.
Yeah. Let us go through. Let us build some date. Uh, I'll filter it to a quarter, or let me filter it by month or year. Okay, I'm taking 4 months, and I am taking, let us pull time to ship. That is the duration we have, right? Okay,
Okay.
and let me take week or something, anything like that.
Why are we taking week and time to ship as discrete?
I will show you. I will let me build this chart first, then I will explain. Let us
Okay.
take segment. Okay, okay. See, so by looking at this, oh, let me take ship mode. That will be even more better. See, uh, now it is saying standard class is taking longer time for shipping, and second class is taking relatively less time, and first class is taking even more less time, and same day is taking just exactly same day. It is same day shipment, right? See, it is time to ship
Yes.
is 0.
Okay.
Yeah. So for standard class, it is over time. In each week, it is taking. In January 2nd week, uh, it is taking 4.357 days on an average to ship a product. It is considering average of time to ship for all the products,
Okay.
for all the orders within this particular week, and under standard class like this. So see, it is a visual representation of duration, right? Activity here,
Yes.
the activity is shipment. We know what is time to ship, right? Time to ship is nothing but difference between order date and ship date.
Yeah.
So this can be represented in a simple manner using Gantt chart. So what do we here? What it tells us? Let's see. See, in this week, either it is standard class or second class, they are taking almost same time. So there is something wrong. We need to address it.
Okay.
We have to interpret it, and we have to investigate what was the reason it is not doing good in the second class. It is an underperform, right?
Okay.
Because uh,
Yeah.
customers are paying for it. When it is second class, maybe it is standard class is free, free shipment, and maybe second class is they are paying some amount of it. So even though they paid something, but still it is not giving that advantage, then we have to know, really take care of it. See, in this week as well as in this week,
Yes.
right? Time to ship is 5 days, even for second class or even for standard class. There might be
Yes.
something we have to investigate further. In we have to explore the data like this.
Okay.
And see, uh, here first class and second class both are taking 2 days. Okay, maybe first class, maybe on an average it takes 2 days. Second class also it is shipping as fast as first class. So second class shipment is doing better than its average. We cannot
Okay.
blame first class here, right?
Okay.
So we have to appreciate second class
Okay.
here. Here,
So how do we know that we don't have to discourage the first class, we are having to
so
encourage the second class?
how do you do that? Let's remove the week number. How much time it is taking on an average across all the weeks? Standard class is taking 4.896 days, 3.218 days, 1.957 days, like this. We know these values, right?
Okay.
So if anyone is taking beyond that, then we can,
Okay. Interpret that it is doing good or bad.
yeah, okay,
Okay.
yeah. So basically, Gantt chart is for representing something duration. Okay, so date is must for it.
Okay.
Okay, so that is about Gantt chart. I mean, here we don't have much samples to deal with Gantt chart because hardly we have only one duration, that is time to ship.
Yeah.
If we can go through more other data sets, maybe it is much useful though. Yeah, let's say
Yes.
uh, within an activity there are multiple stages. Let's say order shipment. I mean, so between order placement and shipment, there can be multiple activities. Let's take order confirmation, then order packing, then um, booking.
Hello?
Yeah, hello.
Are you dragging and dropping anything, or
No, no,
are you doing something?
no, no, no.
Okay.
Okay,
No, no, I see that the screen is stuck, so
okay.
I was just.
I'm audible, right?
Yeah, you're audible, but the screen is not moving, so I thought that maybe you're dragging and dropping something and I'm not able to follow it.
No, no.
Okay.
I mean, here we don't have that, right? So I'm trying to explain some scenarios, some assumptions like that. So it can be like
Okay, okay.
order confirmation, how much time it took for order confirmation, and how much time it took for packaging, and how much time it took for booking courier or something like that. Okay, so each all these events are part of the shipment process, right?
Yes.
So like that we can represent durations for various events or activities which are taken place. Okay,
Okay.
yeah. Let us go through next chart. So we have let us take sales and state. So usually we will have some targets, right? Each and everyone,
Yes.
um, either it is sales or something. Even in IT also will have some deadlines, targets. We have to deliver the products within these days, or we have to reach this amount of sales. Like this we will have targets, right? So when we have targets, whether you reached the target or you did not reach the target, how do we know? So for
Mm,
that, we have a representation, that is bullet graph. Let me take
okay.
a target measure. Let us take. cost as the target. Okay, we don't have target here. I'm taking cost as the target, so sales should reach cost at least, right? Or let me clear this.
Okay.
We'll come to that in a later example. We'll just first understand target. I mean, what is the target is sales, sum of average of all the sales, all the states sales and individual state sales. Okay, let us take.
Okay.
mm, Let me add reference line. This is a target, right? And or we can say above these states are doing good, below these states are not doing good.
Can you just repeat that?
Yeah,
Just the average line. How is the average line measuring like it should to start up at that point? Why is it not starting up after 200K?
it is taking average of all these marks. We
Okay.
have the values here, right? Each mark
But
has a,
that's not the case always, right? It may be the average may not be the always the right way. Maybe we have the targets like around 200K, 200K in this example.
exactly what you can do. You can run.
Okay.
Okay,
Constantly.
yeah. Or
Okay.
if you don't want average, okay, I will go through that later, don't worry. uh, we have
Okay.
next concept, right? We have this one, reference lines and bands. I will go through that later.
Okay.
Okay, so I mean, likewise, we can refer some, what is the actual value and what is the target value, like this. Okay, so otherwise what I can do is I will get rid of this, and what I will do is I will take. Okay, so here what I'm doing, this is sales, this mark is representing sales, and this is representing the cost.
Okay.
These guys has achieved the cost, but these guys did not achieve the cost. Basically it can be target, not cost.
Okay.
Okay, so this is a bullet graph.
Okay.
We have one reference and we have one value. We are comparing the each and every value with the reference.
Why is the reference difference to every value? I
Sorry.
mean, every bar.
Mm-hmm.
Why is the reference different in every case, like in every state?
Yeah, that's what. Each for each and every state, target will be different, right? Target will not be same for everyone. If target is same for everyone, you can use that constant line,
Okay. Okay.
right?
Okay.
So either way, I mean, if target is same for everyone, you can use constant line or any reference line, or maybe most of the times it will not be the same case, because there will be some bigger states, there will be some smaller states. Obviously, you cannot put same target for all the states. Each of the state demographics will be different, right?
Yeah.
So usually it will be different for each this thing.
So, what is the requirement for bullet chart? We need to have one dimension
Yeah,
and one
two measures. One,
measure.
Two
Two
measures.
measures.
Two measures.
One should be on marks and one should be on rows or columns.
Yeah,
Is that also mandatory?
one should be. It will take care of.
On rows,
Once you
yeah, when
select this
columns, yeah.
bullet graph, it will arrange the measures. And let's say you want
Okay.
to swap the measures. You want to use cost for marks and sales for this reference. So what you can do?
Okay.
You can say swap reference lines. Now,
So
copy
here,
examples.
what it is taking as target and what it is taking as bar.
So whatever is there on the rows, it is taking as mark. Whatever is there on the detail, it is taking as the reference.
Okay, so the reference is like target.
Yeah, reference is target, right?
Okay, right. So marks is target or reference you can say or
No, no, mark is not target.
okay.
Reference is target.
Whatever whatever we are having in marks, whatever column,
Mm-hmm.
that is supposed to be as target, and whatever is on the row or column that is supposed to be as a bar. No, sorry, bar is called as mark.
No, see this mark should reach this reference. Always. If that
Okay.
is reaching the reference, it is doing good. Otherwise, it is not doing as per the expectation.
Okay.
And
Yeah, I got the concept. I'm just trying to get like what it is taking as reference and what it is taking as
yeah,
because sometimes
so this is
I don't know which one it is taking as
hmm,
uh, if I'm seeing this, I'm able to understand something is cost and something is
yeah. So
okay sales. But I'm not knowing like okay bar is representing cost or bar is representing sales.
bar is representing sales, and this line is representing cost.
Okay.
Okay,
Okay, so whatever is in the left pane, that is my target. Whatever is in the row or column, that is my mark.
what is lower column?
Row or column,
Yeah,
if
yeah. It is if
the
it is on rows or
measure is
columns.
in row.
True, true.
Yeah.
Yes. Okay.
Okay.
And if it is not reaching the target, how much percentage it is reach? It has reached. See. So there are some
80%.
shades here,
Yeah.
right? So it crossed
Right.
80% here, but it did not
Yeah.
reach target like this.
Yeah.
See, this one also crossed 80%. You're able to identify the
Okay.
gradient, right?
Yeah.
Okay. So like that, bullet graph is helpful to understand, I mean, whether a particular metric is reaching the target or not.
Okay.
Okay.
So whatever we are going through, are these the basic examples? Is there like anything more complicated that you do in real time?
Yeah, I mean, the more complicated thing we will discuss while discussing reference lines.
Okay.
This is basic one only, and of course, even more complicated also for bar bullet graph. It won't be that much complex.
Okay.
Okay, it will be simple one only, bullet graph. But I wanted to discuss with you along with the box plot, so that is the reason I pushed it to today. Otherwise,
Okay.
bullet graph is simple. Box plot is little bit tricky one, so we can discuss them together in line. That is the reason. Okay,
Okay.
fine. So that is about bullet graph. Then let us take box plot. Uh, region. Yeah. Okay. So this is box and whisker plot. We call it as box and whisker plot.
Okay.
In this case, what it is representing is, we have discussed about, I mean, I gave you some reference about standard deviation and all those things, right?
Yeah, yeah.
So this is representing median,
Okay.
and in the same reference I have given upper quartile, I mean the quartiles, various quartiles. Uh, it will have median, upper quartile, lower quartile, like that. Standard deviation. Okay, so
Okay.
this is median, and this is upper quartile, means it is 75% of the this thing.
What is 75% of what?
75% of the standard deviation.
What does that mean?
Uh, you didn't go through that standard deviation reference?
I did go through, but
Okay,
I'm
so
not understanding what you are saying.
okay, so
Sorry.
let us take Excel. So I have some five values, or 10, 15, 15, 20, 22, 23, 24, 28, and 35, then 86, like this.
Yep.
Okay, so
Okay.
what is the median for this? Let me count how many are there. Okay, count is 10. Let us add one more thing. So count is 11 now. And what is the median? It will be something like this. 23 is the median,
Yep. Yep.
right?
Yes.
And what will be the standard deviation? We have to compute it, right?
Yes.
So
That's a
uh,
big process.
let us keep it as some value, some random value. Okay, we're not computing it right now. Let us take some random value.
Okay.
Uh, the standard deviation is, let's say, 45. Okay,
Okay.
or it will not be 45 also, it will be somewhere around 40 maybe. Let us take some value.
Okay.
Now, uh, oh sorry, not 40. It will be the maximum value. Standard deviation will be 15, plus or minus 15, something like that, plus or
Okay. Okay.
minus 50. Oops, it is not accept. Okay, remember that it is plus or minus 15. Okay,
Okay.
so
Okay.
maximum value will be 38. Minimum value will be 8, right? So 38
Okay.
and 8 will be the range for our values. That's what we will consider,
Okay.
right? So this is the concept of standard deviation, right?
Yes.
So if standard deviation is 15, median plus or minus 15. So we'll consider
Okay.
these values as the standard deviation. So most of the values will fall under this range, right? Hello.
Why are we considering only those values? We need to consider all the values for standard deviation.
If we consider all the values, let's say, I mean, we have discussed about something, discounts or something, right? Hello.
Discounts?
We discussed about
Hello?
some example, right? About discounts or something like that. So how much percentage of the discount, cashback.
Yeah, cashback.
We have discussed about cashback, how much percent of the cashback I have to give, and what should be the
Yes.
uh, that return ratio,
Yes, yes, yes,
whether
yes.
it is
Return
15% or
ratio.
20%, right?
Yeah.
So
Yes.
how do you decide those values? It is based on standard deviation.
Okay.
You won't consider these extreme values to define
Okay.
such limits,
Okay. Okay.
because most of our customers fall under this range. We will consider, our target will be on these customers, not on the extreme customers, because these extreme customers, if there will be only very few customers on the extreme side.
Yeah.
The standard deviation will help us to identify those extreme customers.
Okay.
Okay, so all our policies will not be considered by considering extreme customers. All our policies will be based on the our general customers, most of the customers fall under, and where most of our sales will be our contributing. Here there will be
Okay.
one or two customers, but here there are, let's say, 8 customers in this case out of 11 customers.
Okay. So normally when we are doing it in this Tableau environment,
Mm-hmm.
what we do is like this is the data in the database, these all numbers. So
Okay.
when we are passing the standard deviation formula in calculated field, we just pass the column name for that, and it sees what is the top range, what is the bottom range, and it shows us the which who are the most like top customers or like
Yeah,
no
yeah.
he it
So
takes
who
up
are
the
falling?
rare customers and
Yeah,
okay, so it is taking of the rare customers and giving us this. Uh,
exactly.
I mean,
Okay,
the normal customers.
exactly. So this is
Okay,
the
okay.
maximum, minimum, I mean, the most common range. So here in this case, for sales, everyone are looking same common only. So there are no extreme customers here. Let us take some other measure. Let us take discount.
So just this chart is giving us that standard deviation measurement. I mean, in graphical way.
Not standard deviation. It is representing most common customers and extreme customers. It is differentiating them.
Okay, okay.
Okay.
And why are we taking two dimensions right now?
See, it is giving by region. Even though if we take one this thing also, it can. If I take
Mm-hmm.
only one value, then see, we have only one mark, right?
Yes.
So if we have only one mark, how do we differentiate it? Or I can do this way.
Mm-hmm.
So which segment is most common? When we have 3 marks, again, it is tough to figure out a standard deviation and all.
So it is giving segment wise discount.
Segment wise discount we are computing. In this case, what we are trying to do is, see,
So what analysis are we getting out of this graph? When you are seeing this graph, what analysis are you getting?
exactly. So here in this case, what it is saying, in consumer segment, this one, what is this? West region. This is within this thing. So this is median. This is 75% from median. This is below 25. I mean, plus 25% from the median and minus 25% from the median. This is called box. Okay. Hello.
Plus 25% plus.
Yeah, this is median plus 25%, and this is median minus 25%.
Why is it giving like that?
Huh?
It's not clear for me.
It's not clear.
No, it
You're not
is, you
following.
are saying it is
Yeah,
median plus 25%, median minus 25. But in the tooltip,
uh
it is not showing any such cases.
yeah, it is not. It will not show. It will show you the values here. It is, see. It is upper quartile. This is upper quartile. This is lower quartile.
Okay, so
This is
the
me.
upper quartile means median plus 25%, lower quartile means median minus 25%.
Yeah. So it is not percent. It is percentile. Sorry, I spelled it
Percentage.
wrong.
Okay, yeah.
It is percentile. So median means
Okay.
50 percentile, right? You know percentile, right?
Yeah.
Median means 50 percentile,
Yeah.
right? So from that, 75%, 75 percentile will decide the upper quartile.
Okay.
Okay, those are, I mean, there will be four quartiles, right? Uh, I mean, 100% to 75%, 75% to 50%, 50% to 25%,
50%,
and this
50
thing.
to
So
25,
that is,
25 to 0. Yeah.
yeah. So upper quartile means it gives you 75 percentile.
Okay, okay.
Okay, it is 50. Median means 50 percentile. Lower
Yeah.
quartile means 25 percentile.
Okay.
Okay, so this box will give you what is 50%, what is 50 percentile, what is 75 percentile, what is 25 percentile. Okay,
Okay.
and these are called whiskers. Okay,
Okay.
this case it is this one and this one are called whiskers.
Okay.
So what does this I mean, what does this represent is this, between these quartiles we call this as interquartile range. Upper quartile,
Sorry?
interquartile range.
Interquartile range.
Yeah,
Okay.
interquartile range. So between this interquartile range, these are most common customers.
Okay.
Okay, from upper quartile to this whisker, up to some extent, these customers need to be considered. Okay, and then it is beyond this. Let me take another example. I think here also we have very few values. If I take another example, it will be better, I believe. Okay, yeah, now it is better. See, within each region, these states are common. I mean, these states are in common range. Within those states which are in the box, those are most common range. Which are out of the box
Okay.
to whisker, these are little out of the range. But this is extreme.
Okay. Okay. Okay.
These are extreme.
Okay.
You got it?
Yeah.
Okay?
So I just want to become familiar with the terminology in this.
Yeah, yeah.
So, like whisker and
Yeah, this is
quartile.
whisker. This is whisker.
Yeah.
This is box, and box upper limit is upper quartile, lower one is lower quartile.
Okay.
Okay, and we call this as the length of the box is interquartile range.
Okay. Length of the box is interquartile range.
Interquartile range.
Okay.
Okay, and this one by default it takes, this whisker is plotted at 1.5 times the box length, but it is more
1.5 times.
1.5 times the box length. So what is the box length here? It is 53k, 53,555 minus 4,580, right? Upper quartile minus lower quartile. That is the box range, right?
Okay.
How much it
Yes.
will be? It will be around 49k, 48k.
Yeah.
right? It is 48K. Uh, then no, it is 40. Yeah, it is 48. No,
Yeah, something around that. Yeah.
yeah, it is 49K. Okay,
Okay.
so that is the length of the box. This whisker will be plotted at 1.5 times the box. 49 into 1.5, it will be around 73.5. Okay,
Okay.
but it will not be exactly 73.5 because, oh sorry, yeah, sorry,
It is 80.
uh, it is 73.5 from the upper quartile. Are you following?
Okay.
It is
After the upper quartile,
it
it is taking more 73.
yeah, more 73, right? So how much it will be?
Okay.
Upper quartile is 53. That one should be 53 plus 73, right?
Okay. First, it is calculating what is the box length,
Yeah,
and on the box length, it is seeing 1.5 times.
exactly.
Um, 1.5 times 73. So it is taking the upper quartile, and then again it is counting till 73.
Yeah. So it will be 53 plus
Okay.
73. It will be around 126K, right?
Okay.
So
Yeah.
the maximum value can be 126K here. It will be somewhere here, right?
Okay.
But there are no
Yeah.
marks here, right?
Yeah.
So it will take maximum mark value as the upper whisker.
Okay. So why is it not taking the uppermost value? Why is it taking the second
Yeah,
value?
uppermost value is beyond its range. It is beyond 43 plus, sorry, 53 plus 73. 53, it will, the maximum
Okay,
value it
fine.
can consider is 126. Okay.
Okay, okay. So below that, whatever is the starting point, then it will
Yeah.
take that into
Whatever is the
consideration.
maximum, it will
Okay,
take the upper whisker.
okay, fine. Yeah.
Okay. So this is extreme value.
Okay, right.
Okay. These are all the extreme value. The same way it is consider it will compute lower quartile also.
Okay. So again, it will take the box length 49, 49, and then again into 1.5. And from the lower level, it is calculating 1.5 and it is going down.
Hmm.
And then whatever is the nearest to that, not the upper limit, the lower limit, it will come back to that.
Yeah.
Okay. Again, it will take 1.5 itself for the calculation,
Yeah, 1.5 only.
even for the lower limit as well.
Yes, yes.
Okay.
Okay. So likewise, these values are excluded. These values are considered as extreme values.
Okay.
Okay. Fine.
Yeah.
So that is, it is. I mean, you have to be little bit familiar with the terminology. I mean, we have these words here, which are there in the tooltip: upper whisker, lower whisker, and median, upper
Upper
quartile, and lower
quartile.
quartile. That's it.
Yes.
Okay.
Yes.
You have to be familiar with
Okay.
these words. How, when someone can ask you in interview how upper whisker is decided, how it is computed.
Yes. Okay.
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 Fine. So that is the. mm, Okay, and let us take one more example. Will be subcategory. Hmm, Product name, sales. Okay, so it is by subcategory. What are the subcategories within the range? What are the extreme products? Okay, maybe you can consider appreciating these products also, because they are performing much better than anything else, right?
Okay.
So
Yeah.
you can appreciate them because they are out of the, I mean, they are doing above average,
Yes.
right? So you can consider
Yeah.
it.
So
It is, if it is good.
if you're hovering,
Hmm?
if you're hovering over those product names, are you be able to see the product names?
Yeah,
Okay. Okay.
I mean that
Yeah.
depends,
Okay.
right? We can
Even the
use
same
labels
way.
however we want. We can. Did we discuss about
Okay.
labels? We
Okay.
discussed about labels, right?
Mm, yeah. 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 We got all the marks and everything.
Yeah.
Yes.
Okay.
Okay.
So likewise, this box and whisker plot can be useful to figure out some things which are beyond the general range. Okay, and if you would like
Okay.
to consider, I mean, if it is good, if this metric is positive, then you can consider these values. If this metric is negative, then you can ignore these values. I mean, it depends. If it is discount,
Okay.
this is bad, right?
Okay.
In this case it is
Yes.
discount. So here it is offering 25% average discount. It is bad. This region central and consumer segment is not doing good because it is offering
Okay. Okay.
25%
Okay.
discount. And at the same time,
Yes.
here it is, what is it, is sales, it is good. I'm happy with this
Yes.
because
Sales should go more. Profit should go more.
hmm,
Sales and profit are good whenever they are going on.
exactly. Okay, so likewise it depends upon the metric, whether it is positive or negative, which one we concentrate on, whether we concentrate on out of the extreme values or within the range values. Okay.
Okay.
Yeah, so that is about box and whisker plot. Fine.
Okay.
And all of these are computed by using these things: reference lines, bands, distributions, and box plot. So we can customize this, we can build it ourselves instead of using the default options. It need not be,
Okay.
we cannot just use this one or bullet graph like this. We can build it ourselves, we can customize it as per our wish. Let us go through how do we
Okay.
customize it. First of all, we'll start from reference line. So let us take sales, and if you want average line, you can draw average line, or you can, let's say average is not good for you, it is one value, and if you want something else like this, you can decide a band. Here what do we do? We will use two values, one upper value and one lower value. Okay,
Okay.
so instead of one
So
limit,
we can only select mean, median, max, and low
yeah,
to decide reference band.
see, these are the options we have. We can choose a
Okay,
constant
we
value.
can only use these.
We can use a constant
Okay.
value, minimum, maximum, average, or median, sum.
Okay.
Okay,
Okay. Okay.
we can use constant value also, not at all problem.
Okay.
Okay, so all these are I mean, if you're not interested in a single reference, you can keep them in a range. Whoever is falling within this range, probably you can give something like that. Let's say some people are falling this range, we can give you some appreciation like five
Special
percent
discounts.
or 5% hike or something like that. Whoever is falling above this line, above this band, you can give them maybe 10% hike like that. Okay, whoever
Okay.
is below this line, maybe you give nothing.
Okay.
Okay, so
So, how do I select those people? Like, they want to give some discount, so they want to know.
see, this guy
Okay, they
is
are getting
typically.
the idea about it, but how are they able to select those
Hmm?
particular customers or particular products?
I didn't get you.
How are they able to get those particular customers or products exactly? It's like, okay, I'm getting the band, I'm able to see, I'm able to get some analysis.
Mm-hmm.
But when I want to give those each particular customer
Mm-hmm.
some discount or something, then how am I able to do? Are we able to send some data back to the client for that?
I'm not getting your question actually.
Okay, what I'm saying is there are people who are falling in that bandwidth,
Yes,
reference band.
yes.
Okay, suppose that uh, the client is asking you to pick all those customers
Mm-hmm.
who are only in that band.
Okay.
So, are we able to do something like that?
Yeah, why not? Why don't you create a calculated field? And one value, upper limit is average and lower limit is median or something like that. We can define a calculated field and you can use logical operators, if else like that, and we can.
If we say median average in the calculated field, it won't give us the same range, I guess.
It will. Why not?
Will that?
Yeah, why not? It will.
Mm,
It is a computation, right? Ultimately, it is a computation, right?
yeah, it is,
All
but
this is,
still,
we have all these functions, right? Minimum, maximum, average, median, sum,
yeah.
everything.
Okay, okay,
Okay?
yeah,
Okay, fine. So, I mean, here this is visual representation. If you want to filter out them below median, above a median, above average, you can absolutely you can do it using calculated fields.
okay, okay. Yeah, that's what my question is.
Okay, fine. So, if you have one limit, you can use reference line. If you have multiple limits, two limits, you can use this one band. If you have more limits, not two, then you can use this thing distribution.
Okay,
See here you can set the limits 60%, 80%, 40%, or
so we can give more than two
yeah, more than two.
in distribution, like more than two, three,
Yeah, in
four, five,
distribution.
10, 20, how many ever.
Yeah, exactly.
Okay,
Okay, you can decide percentages. If it is giving you 60% of the average like this, you can change it to something else, maximum value. See what we are doing, we took this is the maximum value and this is the 80% of the maximum value, 60% of the maximum value, 40% of the maximum value. Like this you can define, sorry, you can define different ranges, you can give more.
okay,
Okay, so when you have
okay.
more than two, you can use distribution. It can be anything, any uneven value also. It need not to be even.
Percentages, percentiles, quartiles,
Yeah.
standard deviation.
Okay.
Okay, depending on all those, again we can do. So, how will the client's requirement come up for these kind of situations?
So they will have multiple targets basically. They will have a forecasted value. They will consider average of history like this.
So, some example can you just tell me that you have encountered?
It is a based on, I mean, they have some forecasted value based on their analysis, their the market macroeconomic data and all. uh, their estimate is they will improve their sales. I mean, they will achieve the sales target of, let's say, 100K, but they
Okay.
may not reach it. That is
Okay.
acceptable if they may not, if someone reaches cannot reach it. But there will be a minimum value which cannot, they cannot fall below that minimum value. The minimum value will be average of the last 3 months.
Okay.
Okay, they'll consider last 3 months data, last 3 months sales, and you cannot fall below that. If you are falling below that,
Okay.
it is very bad of you.
Okay.
Okay, if you reach the target, there will be appreciation, but if you fall below this last 3 months average, then there will be punishment. If you fall
Okay.
between the range,
So
it is good, it is okay,
if
you
we are
are safe.
okay, so when we are selecting percentages, it is taking the um okay, it is taking like how much our percentage we are giving there. When we are giving uh, quantiles,
Mhm.
then what will it take?
So it will give you four. Quantile means four, right? It will give you four bands. Okay, we discussed, right? Lower quartile, median, upper quartile in the whisker
Okay.
box and whisker plot. It will give you those quartiles: 25 percentile, 50 percentile, and 75 percentile. It will divide into four quartiles. If
Why
you,
is the upper quartile not the upper limit of the bar?
what it is taking here, it is computing average.
Okay.
Okay, I mean, what would we choose? Yeah, it is taking average. Or
So
no, no, not
average is
average.
the
Sorry, sorry.
at most.
It's not average. It is considering uh, by that standard deviation and all.
Okay.
It is
So it
75.
has its own computation.
Yes, yes. You can split into more also. It is not only four. You can split into three, tercile in this case.
Okay.
So 33 percentile, 66 percentile, below 33, between 33 and 66 percentile, and above 66 percentile. Okay, it is tercile.
Okay. So it's
If you have,
computing according to percentile.
yeah, if it is 5, it is quintile.
Yeah.
0 to 20 percentile, 20 to 40 percentile, 40 to 60 percentile, like that.
Yeah.
Okay, if you have below 6, I mean above 6 also, it will be like that only. So you can define any number of that. So up to 10,
Okay.
0 to 10%, 10 to 20%, like that also.
Okay.
Or you can pass a parameter, how many tiles you want to separate it on.
But they pretty much gave us like 10%, 10 things.
Yeah,
So we
it
can
can be
just
beyond 10 also.
select anything.
It can be beyond 10 also. It is option, or within 10 only you can choose using parameter,
Parameter. Yeah,
using 3
exactly.
or 4 or 5.
Yeah.
Okay, so well, that's
Okay.
where parameters are everywhere.
Yeah.
Okay.
And n value?
Hmm?
N value in that?
No, that is a parameter we have. Those are
Okay.
the various
And bin
parameters.
size?
We have created parameters in the previous example, right?
Yeah.
Let me show you.
So bin size is different, right? Bin size is with
Yeah,
the
it is a parameter.
other
It
graphs.
doesn't matter. It is a parameter. So these are all the parameters we have. All these parameters are
Okay,
available
okay.
there. We can use whatever parameter we want.
Okay, fine.
It doesn't care how, what is the meaning of it here. It is a parameter,
Oh,
and it works in sync with that parameter.
okay,
You can
fine.
create a new parameter,
Okay.
or you can choose an existing parameter.
Okay, okay. Okay, fine. Yeah,
Okay.
got it.
Yeah. So that is about various options for the distribution we have. We can choose standard deviation, whether it is sample or population, we can choose, and we have some factors for it, standard deviation factors also. If you go through it once again,
Yeah.
you can simply understand it. Okay.
Okay, yeah.
Yeah.
So
So
why again sample and population?
yeah, sample and population. We have gone through it. See, we are working on, if let's say if we are working on a survey data.
Okay.
Okay, so survey data is a sample of the entire market, right? Let's say there are 1,000 customers, survey will be conducted on 20 to 30 customers, right?
Okay.
And that is a sample. Based on this 20 to 30 customers interest, what do? We will project it for the 1,000 customers, right?
Mm, no, I
And
didn't
what do
get
we
it.
do? Let's say there is a exit poll, opinion poll in the some US elections.
Okay.
So Hillary Clinton is supported by 55% people. Trump is supported by 45% people. That's what is the opinion poll result will be there, right? So does really
Um,
all the citizens of US participate in that poll? No, right? Only very few of them will be participating in that role poll,
yes.
right?
Yes.
So that is a sample. That is not actual. That is not actual representation of the entire population. It is just a sample of the population. So while computing
Okay.
standard deviation, if you have sample, there is one formula. If that is population, let's say you are working on some historical data, which is all the which you have all the which you, in which you are considering all the population, all the people or all the customers. There is no projections or anything. Then we use population.
Okay. So population means that it has to consider any drastic
No,
measures as well.
population means it is considering all the data. There is no projections
All
or
the
there is
data,
no
like
assumptions.
assumptions. Like in the sample, when you said when we took the Excel sheet and we took some example, it is only taking the values that are like closer to each other. But when we are taking population, it can take zero, it can take like 100,000, whatever is the upper limit. It
No,
has to
I
take,
think
it
you
has
are
to must and take, must
no,
and should take.
no. You are understanding it in a different way. So sample means it is we are computing, we are working on a subset of the entire original data,
Okay.
and we are trying to apply those values for the entire values for entire customers or entire population.
So how is it taking the sample again? Is that the most popular values, or is it like
Yeah, I mean that's
anything?
no. So that depends upon, in the case of US poll, that will be random values. Okay, let's say
Yeah, that's
someone
what
else like
random.
Nielsen, they are conducting a survey, product survey, something like that. So that will be, then in that case, sampling will be different. Sampling is an art actually. Okay,
Okay.
so
So when we are
they will collect
sampling,
opinion from urban people and rural people, and middle class people, and super middle class people, and luxurious people, and below poverty line people, everything.
okay,
So sampling, I mean, it differs. It is absolutely it depends upon uh, the organizer of the survey.
okay, okay,
So it is not actual value, but still we are trying to figure out some value by considering that sample.
okay. So when we are selecting sample, it is automatically doing all the computation for us, and it is giving us the data that has to be projected in this way.
I think if you go through that reference once, it will be. you can quickly catch it. If you cannot understand it after going through that reference, we'll discuss again.
A reference with the standard deviation?
Yeah.
Okay, okay.
Okay.
I went through the calculation and everything, but I did not go through.
No,
Okay,
and then
I'll
there is
just
a
see one.
population. There is a different formula for population, and there is a different formula for sample at the end.
Okay, okay, okay.
Only just the
Okay,
denominator differs.
okay,
Okay, just go through it once, and if you cannot follow it, we can discuss again. Okay,
okay, sure.
fine.
Okay,
So that is about distribution. So you can give as many as values as you want to different ranges, different references. These are nothing but references, right?
yes.
Different references like this. So you can choose different things also, parameters as part of it. It need not to be a measure, it can be a parameter also, or it can be some other measure also. As the reference you can choose. If you want to use some other measure, that has to be on the this thing, detail. You have to pull this into detail, and now it will be available here. See, cost and sales, whichever measures are in the view, those measures will be available here.
Okay, okay,
Okay. Yeah,
okay. Yep.
you can choose cost. See, it is computed on the cost, and there
Okay,
is let me copy this, and you can choose box plot also from here itself. Okay.
okay.
So we discussed it, right? Data with 1.5 times the IQR. IQR means interquartile range.
Interquartile range. Yep.
Yeah. So let me disaggregate the data here. Okay. So, and if you can extend the whisker to maximum value of the data also. It's not mandatory to keep it here at the 1.5 times only, but it is
Okay,
most suitable. If you look at it,
okay,
if you gone through this, see, edit reference line, and here you can change it. If I choose maximum, see, if I choose 1.5 times, it is only here.
okay. Got it.
Okay,
Yeah.
but this is most recommendable, most common usage. Okay,
Okay, okay,
so you can customize box and whisker plot uh, like this by just after clicking box and whisker plot, you can go to edit reference line and customize it like this, or you can change the color, change the style, and you can say hide the marks which are inside this box like this. Okay, you can hide them, or you can change the fill color. Okay, and you can change the borders.
mm. Hide means what it is hiding?
It is hiding marks between this.
In the range.
Yeah,
In the range.
underlying marks.
In the interquartile range.
Yeah,
Okay.
not only in the interquartile, all these things within the whiskers. See,
Okay, even in the whiskers as well.
yeah.
Okay, okay.
Okay, it depends.
Okay.
If it is a positive thing, you can consider these things.
Okay, okay.
Okay, so like that, you can customize whisker color like this, whisker width, everything. Okay,
Okay.
so that is about reference lines. Let me copy this. So you can choose average or median value, anything, or what you can do is let see here, instead of applying for entire thing, what I can do is, let me pull another region here. Okay, see, this average is computed for per pane. Now within, for each region, the average is computed. Now what you can do, you can say entire table, the average is for computed for all the states across all the regions, or those states which are in within the region, or you can compute it per cell, means only for that state. In this case,
Can you just repeat that?
yeah. So the scope of it, what is the scope of it? It is average across all the states, across all the regions, or average of those states which are within a region. Average is this line is getting
Within.
changed. See, and
Okay.
only for that particular state. So if you pull this, if you use per cell,
Cell is
it
state.
will be a bullet graph, right?
Yeah, it is bullet graph. Yeah.
Exactly. So it can be like this also.
Okay, it is showing state. How is it considering that uh, target?
Which one?
Here it is showing some bar on top.
Uh,
Yeah. So how is it considering that?
which one?
The top bar, the
Ah,
target bar.
the reference.
Yeah.
Yeah, that is
Yeah,
what
reference. Yeah,
that is
exactly.
what we are using, right? Reference. So here it is.
Here we are using reference, but how is it calculating?
It is cost. We are using cost here.
Okay, cost.
We are using cost as the
Okay.
reference.
Okay, cost as a reference on sale.
Yeah.
Okay, okay, okay.
Okay. You can
Okay,
compute
okay.
it
Yeah.
per cell, per pane, or entire table,
Okay.
and you can choose the different aggregations. Is it average or is it this something else? You can choose. Okay.
Okay.
And if you want confidence interval, this is also another thing. Let's say some above 5% or this thing. For this average, if I want to apply some confidence interval, let's say you are dealing with some forecast, some target. So
Okay.
this is the target value. Okay. So, but the target is just a forecast, right? It can,
Yes.
it need not to be same. So it, you can give some confidence interval. It can be plus or minus 5%, like this. So you can
Okay.
choose a confidence interval also for that. You can choose
Okay. Okay.
like this.
Okay.
Okay. If you are it depends upon your forecast accuracy. You can
Okay.
increase this bar.
Okay. So, like they are expecting something that's forecast, and it can go above or below
Below
50% or 80%.
that. Exactly.
Yeah.
Okay.
Okay. So it
And
should lie in that range.
hmm, and you can show only confidence interval, or only line, or both line and confidence interval. Okay.
Okay.
And you can choose the confidence interval value also. Okay, like this. And
When we are selecting only the line,
mhm,
okay, that is again disabled.
yeah,
Exactly. Okay. So that is the forecast what they are expecting.
yeah, it can be forecast value. Okay.
Okay.
And let's say, just a second.
Okay.
Hello.
Hello.
Yeah. So here we have the label. We can change the label however we want. We can show it is average, right? We can show the value of average instead, or we can completely hide the labels, or we can customize it and say I want computation and as well as value. Okay,
Oh,
I can customize it. See,
okay.
so we have multiple options here.
Okay.
You can customize it, and here we have formatting options. You can change the line and apply the different colors for it, or you can fill it above the line or below the line. You can apply different color like this.
Okay.
And this one, see, show recalculated line for highlighted or selected data panes. So if you enable this, what happens is this average will will change based on the selected marks. Can you notice this?
Okay. Okay. Yeah.
Now average is here. If I select particular marks, this is computed only for the those selected marks.
Okay.
If you hide this,
So it is at a time. At a time, it is selecting like only one. At a time, it is only computing for one mark, or we can
it
select
is
control
considering
and.
those selected marks and computing the average. In this
Okay.
case, it is average,
We
right?
can select. Okay, we can have hold control and select number of marks again and
Yeah, yeah, we
see
can
the
select.
average.
Yeah, that's what.
Okay.
So now I have unchecked it. So even though I selected it, the average line is not getting changed, right?
Right.
If you want to change the reference line by selection, you can choose that and choose the this thing. It is.
Okay.
So those are the various options we have to customize these lines, reference lines. And for bands also it will be same thing. So you can choose whether to update as per the selected marks or something. You can apply formatting for lines and apply fill colors. Okay, like this.
Yeah.
And you can choose labels. You can apply different measures here. It need not to be cost and minimum maximum both all the times. It can be something different measures. It is like target value and some uh, average value like that.
Yeah.
Okay, so the upper limit will
Okay.
be target value. The minimum limit will be the average of the last 3 months, something like that. Or you can use a
Okay.
parameter also.
Okay.
Okay, so band you can customize like this. And distribution also you can use what is the different values, percentage or percentile or quantiles or standard deviation and different measures, whatever parameters you want, different computations. And you can customize labels, and you can change format all these fillings. And you can fill above, okay, or fill below. Okay, fill above, fill below, or you can say let me choose this one, symmetric. Okay, see, if you don't choose symmetric,
Okay.
it is showing you different colors here from
Yeah.
above the line and this range, the band, it is showing same color.
Yeah.
If it is symmetric, it is showing same color. Okay, and you can
Okay.
apply reverse colors however you want, and you can
Okay.
apply filling below this like this.
Okay.
Okay,
Okay. Okay.
so likewise you can do lot of customization. And same thing, uh, actually that bullet graph is computed using distribution and parcel.
Yeah.
See, where is that? This one, right?
No screen. Okay.
See, one is average cost, and another one is the distribution.
Okay.
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 So all those things are, we can customize ourselves, right? We don't need to use these things. We can use them as shortcuts, these graphs, but we can customize it using the reference line, constant line, median and quartiles, all these things, reference bands, and we can remove this anytime, remove all reference lines, or remove particular reference line, or edit reference line, any particular reference lines, or swap it. You can use it in multiple ways.
Okay.
And it is most commonly used. Reference lines and bands, these are most commonly used.
Okay. Okay.
Okay?
Yep. Electronic settings.
Clear, right?
Yep.
Fine. Any questions?
Not at the moment.
Hmm?
Not now.